Okay, so today we're going to go back and take a look at the 2012 AP Calc AB multiple choice test. We're not going to do all the questions from it. There's definitely some I'm going to skip. We're going to do it the same way we've been doing it, where like we do it, boardwork style, where I show you the problem, you give it a shot, and then I'll flip to the answer, and then I'll go through the answer. The way my answers are done in this are a little bit different from how I've done them before. I'm using an old document that I have from school from previous years. So it's not going to, my solutions aren't going to have as many details, but I'll walk through everything that I do. Um, uh, these are all, this test is publicly available on the College Board's website. So I'm taking all those problems from there. I'll put a link to maybe their document and then another like smaller version that I have. The last thing I was going to say is that some of these might even be problems that we've done previously over the last couple of weeks. So maybe when we get to some of those, you can do them pretty quickly because you're like, oh yeah, I know how to do this, right? And then others will be totally new. So first one, they give me y equals x sine x and ask me for a dy dx. So you're just going to make sure you can use product rule correctly here. So go ahead, hit pause and figure out which one your answer is. Okay, here it comes. I got B. I did the derivative of the first, which was 1, and then I wrote the second. So it was 1 times sine x plus x times the derivative of sine. So I get x cosine x. Hopefully you got that one. If not, you see what you did wrong. All right, so let's go to question 2. Okay, so let f be this function. It says on what intervals is the function f increasing? I'll give you a little hint if you want it. Okay, so your little hint is if I want f to be increasing, I want to know when f prime is positive. So you can make the chart that you do for the first or second derivative mins and maxes test and look when the f prime is positive, or you can use other methods. So go ahead, hit pause, give it a shot. All right, so here comes my solution. I didn't quite do the chart, but I'll walk through what I did. I got B, negative 10 to 10. So, and this goes back to what I was saying earlier about like not showing as complete a work as I normally do. Like this is just stuff that I did on the board in class a long time ago, and I have the document saved. So the first thing that I did was I took the derivative of that thing. That gave me 300 minus 3x squared. Oops. Then I factored the 3 out to make it a little bit easier. And then I got 100 minus x squared. So I looked at that, I saw a difference of 2 squares. So I got 10 minus x times 10 plus x. From there, you could make your chart that you guys are pretty familiar with making. What I did here instead was say, well, this is just a parabola, right? See the minus x squared parabola thing there? So let me just put a intersect at negative 10. That would be this one equal to 0, and intersect at negative 10 here. That would be this one equal to 0. And then graph a parabola that, why does it go down like that? Well, because this x squared term is negative, right? So it's a parabola that opens down that hits at negative 10 and 10. That is f prime. I want to know when f prime is positive. So you can see that from negative 10 to positive 10, this guy is above the axis, so I answer B. Let's do the next one. All right, so here they give me a function, and they want me to find f prime of 1. Just be careful with all your little pieces. They're just trying to catch you in some common errors here, and see if you can get what the derivative is. All right, I'm going to show the answer in a moment. Hopefully you've pressed pause and you have an answer. Okay, so the answer is E. I actually don't have the full done solution for this one. on my other document, so I just did it on this little post-it thing. F prime, well, that is the derivative of each of these terms. So f prime of this, or the derivative of this thing is 7. Derivative of minus 3 is nothing because it's a constant. And the derivative of ln is 1 over, or ln of x is 1 over x, which gives me 7 plus 1 over x. Then I want to find f prime of 1, so I get 7 plus 1 over 1. Well, that's the same as 7 plus 1, which gives me 8. So the answer is E, 8. I actually accidentally skipped this one, so we're going to go back up to 3. Doesn't really matter the order in which we do them. So here they want me to do the integral of secant x tangent x. This is one you should know. There's no u sub or anything. All right, here comes the answer. Oops, where is it? There it is. I get A. It's literally just like this is the derivative of secant, right? So I want to know what would derive to that. Well, I know secant x plus c. So the answer is A, secant. Secant, tangent, you know what I'm saying. I'm on the internet here. All right, next one. Let's see, I got to zoom out a little bit. All right, so here it is it's all limit and continuity stuff, right? So, which of the following statements is false? So you want to go through and check which of these work, right? Is that true? 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 One of these is going to be false. So see if you can do that. Answer is C. So take a look. Limit as x goes to 2, right? Well, remember, it doesn't have to be continuous for a limit to exist. And really like a limit is the left and the right, do they go into the same thing, right? So here, what's it come into from the left? 2. What's it come into from the left? 2. Good, so the limit exists. A is correct, right? So I'm going to cross it off. Limit as x goes to 3. Well, boom, boom. From the left side and the right side, they both go to this y value of 5, right? It is continuous, but that doesn't mean that the limit doesn't exist. So I cross off B. All right, 4. Left limit, well, that's 2. Right limit, that's 4. I need those two to go to the same spot. So that one seems like it's the one that is false. Whenever I get one of these questions, I always go through and check the remainder of them, right? So I'm gonna like hold that in my back pocket. I think C is the answer, but I'm gonna check these two to make sure that the AP is not fooling me. D, limit as x goes to 5 exists. Well, look, it comes into 6, comes into 6, we're good there. And then is it continuous at x equals 3? It is. So yes, indeed, my answer is C. We're going to do 7. Okay, so look, they give me y is this thing, and they asked me for y prime. So you're going to do some chain rule, be really careful with all your positives and negatives, and notice that they don't really totally simplify this. So go ahead, hit pause, get this one. This is one you guys should be able to do. Sorry, answer came fast, maybe. I got E. Um, let's see. The answer's in front of us, so it's kind of like a process of elimination question. So I know that I have to do power rule. 5's going to come out front, right? Well, look, all of these have 5, so that's not going to help me. Then I've got to have uh, which is the innards, to the 4th, right? Well, I can definitely cross off this. 5, there should be a 4 up there, right? This one, this one. So how do I cross those off? Well, we need to have the chain rule piece. What's the chain rule piece? It would be the derivative of the innards out front, right? So we need to have a derivative of that would be 3x squared. Derivative of that would be, what's the derivative of cosine? It is negative sign, but this is already negative, so it should be a plus sign, right? So notice this one has that guy repeated in there, and then what I just said. Oh yeah, sorry. This one has 5 to the 4th, but then it doesn't have the old innards in there. It has the derivative piece in there, right? Here, it's written like kind of flipped from how we normally do it when we're in class. but it's 5 times the chain rule piece, the derivative, and then to the fourth, right? So the answer is E. Let's see if we can get another couple in. I'm going to go to 8. Okay, so this one is sort of a context problem. We want to do, it says, you can read through the whole thing, but they tell me that tank has 50 liters in it. This is R, it's the rate which is pumped in, oil is being pumped in. They give me selected values of R, and then they want me to use a right Riemann sum with 3 subintervals to approximate the number of liters of oil in the tank at t equals 15 hours. Now there's this problem definitely has some bait in it. There's a super common incorrectly selected answer here, and it has to do with this 50. Um, uh, but the other thing is that make sure you get your distances in this t here, that you look at the gaps for your sum. So hit pause, give it a shot. Here comes your answer. Oops, it is C. I think that many of you might have gotten A. Let me explain. So, and oh, this is one that bothers people when we talk about it in class, because look at these numbers. I got to do this and this and this, right? So this is uh, actually on the no calculator section, but that's not something you guys have to worry about in the 2020 year because you guys are allowed to use a calculator. So, all right, let's look at this. The gap between 4 and 7 is 3. Gap between 7 and 12 is 5. Gap between 12 and 15 is 3. I always do that. And then we're doing a right Riemann sum. So I circle the 3 that I'm going to multiply by. I'm not using this one on the left. So I'm going to do 3 times 6.2 plus 5 times 5.9 plus 3 times 5.6. That's what I have written down here. You can ignore what I wrote there with odd. But if you do that, punch it into your calculator, you get 64.9, which is why I think that many people answer 64.9. But remember, that integral is representative of the change in the amount of oil in the tank. That's how much, this is the rate that is being pumped in. So when I integrate it, it tells me how much came in, right? Well, look, it started with 50 liters. So what do we got to do? We got to take that 64.9 and add 50 to it. And that's how I get that 114.9. Okay, we're going to get one more in here. Here they let f be the function defined above, and then they want me to make it continuous. So if you know how to do this, go ahead and do it. If not, I'm going to give you a little hint. Okay, your hint, look, this is what it is at x equals 2. Or sorry, this top line is what it is when x is not 2. Notice if I try to plug in 2 to this thing, I get 0 over 0. So they want me to figure out what value of k would plug the hole. This thing has a hole at x equals 2. They're essentially asking me a limit question. They're asking me the limit as this goes to 2, or as limit as x goes to 2 of this thing. So, and then we're going to make k equal to that limit because it'll fill that hole. All right, flipping over to the answer. Answer's E, 5. This is one that I would typically talk about a little bit at the board, but all I do is cancel my x minus 2's, and I'm evaluating this limit at x equals 2. So I cancel my x minus 2's, and then I can plug in my x equals 2 value, which gives me 5, right? So if I make this 5, this thing's undefined at x equals 2. But if I make k 5, then it'll make, because I get 2 times 2 plus 1, which is 5. If I make k 5, then it makes this thing continuous at that x equals 2. It makes it so that this guy is the value that this guy doesn't get to at 2. And we will pick up in another video we're actually going to go, I think, to question number 12.